Hello, I am Associate Prof. Dr. Malik Ali Anagre. Today I will talking about the plastic composite and also I will talk about the one published paper in this field. A composite material consists of two or more different materials whose mechanical properties complement each other, although they maintain their separate identities. Unlike an alloy, also, there are some examples or common example about the composite. For example, here, a clay is reinforced with the straw to produce a structure with a greater strength. Another example is reinforced concrete with the steel rod, strengthening the concrete matrix. Also, we can consider the wood as a natural composite, its fibrous composition. Nowadays, public concern about the environment, climate, emission of gases, and energy consumption. So they will increase the focus on the use of natural and degradable material in application. Replacing metallic materials with polymer has become also an important in modern industries to reduce the cost, time, and easy to manufacturing processes. Most synthetic polymer are produced from non-degradable petrochemical, and as you know, the petrochemical are harmful to wildlife and source of environmental pollution. Using using the natural fiber, and here, as you know, natural fiber enter in many applications, and also it is the most appropriate solution for integrating public concern to reduce the cost and time. Advanced engineering materials such as polymer natural fiber composite are used in various components such as aircraft structure, car, helicopter, ship structure, boat, and structure engineering applications to replace metal with the thermoplastic or thermosetting composites. Mechanical properties of the thermosetting composite must be enhanced and always must be enhanced to make to be a good candidate to replace the metals. Thermoplastic or thermosetting composite, natural fiber and epoxy offer many advantages such as low cost, material obtainable, simple manufacturing technique, low density, high degradability, not harmful to the human body. In this study, I will talking about one published paper in this field. In this study, improve the mechanical properties of the thermostatic composite, epoxy, dalt palm fiber by using a new fabrication technique. This new fabrication technique was silicon mold, also type of the fiber, leaf sheath, and weight ratio of the dalt palm fiber. It was 5, 10, 15, and 20 weight percent of dalt palm fiber in the construct to the previous study. In terms of the type of the fiber, dull bond fiber ratios, fabrication method, type of mold, and mechanical test. It was observed that most previous studies used the hand layout technique as the fabrication method. But in this study, the fabrication technique was the silicon mold. And from this slide, we can see the natural fiber, this one, and also we can see the silicon mold cavity using to fabricate the samples or the specimen such as creep, impact, and tensile. And also the epoxy dust palm fiber have been synthesized and characterized successfully with various reinforcements of dust palm fiber. We prepared the silicon mold and then pouring the mixture of the fiber and epoxy in this cavity. The cavity it was for the mechanical test cavities, as show, or we can see this one, the cavities or mechanical test cavities from this figure. Also here in this slide, you can see different type of specimen with different ratio of the double fiber epoxy for different ratio 5%, 10%, 15 and 20. And these are our samples, and also we conducted the mechanical properties. The first one was for the mechanical properties for the hardness Brenel. We can see here the results of the hardness for different ratio of the fiber, different weight ratio. The maximum one it was for the 15 weight ratio of the fibers, and this maximum result due to the good bonded between the matrix and fiber. And you know, with if we as the result, when we increase the ratio of the fiber, the hardness decrease due to a lot of porosities during the process or during the pouring the mixture in our silicon mold, and also due to increase the impurity inside the structure of the composites. Also, if we're talking about the impact strength, we can see the ratio or the impact strength increase with increasing the ratio of the fiber to reach the maximum one in for the 20% with ratio of the fiber, and this increase due to the stress transfer from the matrix to fiber, and also because the increasing the fiber in our composite or in our specimen increase the ductility, which lead to increase the impact strength. About this slide, we're talking about now about the creep strain, and we can see also increase in fiber for 1 minute, 2 minutes, 3 minutes, 4 minutes. For blue one, for 5 weight percent of fiber, red color represents the 10 weight percent of fiber, green and purple, all of them talk about the ratio or weight ratio of the fiber for 1 minute, 2 minutes, 3 minutes, 4 minutes. And from this figure, we can see the 20% or 20 weight ratio have a maximum creep strain, and the maximum strain is obtained using the ratio of 20% of dust pulp fiber due to the reduced rigidity of the brittle epoxy matrix. About the last mechanical test, tensile strength of epoxy dust pulp fiber composite for different ratio of dust pulp fiber, 5, 10% or 10 weight percent, 15, and we can see also here the maximum tensile was for the 20 weight percent of fiber, and this one because it's the sufficient dust pulp fiber in addition to easy and smooth transfer of applied longitudinal stress between dust pulp fiber and the matrix. Thank you, and I hope this one or this published paper useful to our field composite material. Thank you.